The nice thing about doing experimental physics is that a physics laboratory is really a church. You walk in and you ask God a question, and if you ask it very carefully, you will get the correct answer. If somebody else walks into his or her church, physics laboratory, and asks exactly the same question, he or she will get exactly the same answer that you got.
I think you have a really unique story that when you had like a chance on embark on this Nobel caliber work when you were a grad student. And now there's like new generations of scientists who are in their 20s and thinking what to do next. Do you have anything like share from your experience? Any like piece of advice you could give it to them?
Develop a sense of honesty. Number one, do good science. Number two, calculate things accurately. These guys who are, and report exactly what you see. Don't make it up because that's what they're paying you to do, which is exactly that is exactly the opposite of what's been done in climate science. Climate science is all total pseudoscience at the moment, in my opinion.
But let's say if you're a physicist today, what kind of thinking might help physicists or chemists, biologists, something like that? What kind of thinking might help find a problem that's like tractable, but people aren't working on it, that kind of thing? Like, how do you search for a problem like that?
I can tell you what I do is be observant, pay attention to everything you see, at least do order of magnitude calculations to see if it makes sense. And if it doesn't make sense, this is a piece of advice that my dad gave me. Always go back down to the original data behind the theory and ask yourself, if I had done that experiment, would I have come to the same conclusion from the data that you actually took? In most cases, you find that that's not at all true. In Einstein-Podolsky-Rosen's time, none of the experiments that I did or subsequent were at all possible. Just the technology didn't seem to exist. The tricky bit in being a physicist is to try to be both an experimentalist and a theorist at the same time. That's why Dickey was one of the greats who did actually look at what the data actually say to you. Do they really make sense? Or do they come to the conclusion that you want or not? And if it doesn't come to what you want, keep looking. And if you still can't find it, then maybe what you want is not what's true. The important thing is to at least be honest with yourself and admit when you don't understand it, and drill down to the original experimental evidence to see, does it really truly all make sense?
Is there anything else also what we didn't cover in this conversation what you would like to add on top of that?
So for what I did, I was having fun. I literally, the neat thing about doing experimental physics is that literally you're talking to God. And I can say that even as an atheist. You're asking God, or physics, if you will, very fundamental questions. And the nice thing about doing experimental physics or physics experiments is that a physics laboratory is really a church. You walk in and you ask God a question, and if you ask it very carefully, you will get the correct answer. If somebody else walks into his or her church, physics laboratory, and asks exactly the same question, he or she will get exactly the same answer that you got. That's the nice thing about doing experimental physics. Nature is reproducible. Now, find me another church, another religion in which you walk into one church and ask the question, and you walk into another church and ask the same question, that you always get the same answer. You are asking fundamental questions about nature. If you want to call God, nature is God, if you will, if you're an atheist.